Hi folks, today we're going to talk about similar triangles. The word similar in itself means that you're going to have two shapes that are the same shape but different sizes. The symbol that we're going to use for similarity is a little sideways squiggle. Okay, let's go to the next page. We're going to look at trying to see how much information we need to show that triangles are similar given certain conditions. One of the first rules about similar triangles is if you have three sides of one triangle that are in proportion to three sides of another triangle, then the triangles must be similar. So we're looking for all three sides are in proportion to the other three sides. If you look at these triangles, we'll give some values to the side lengths. So we're going to call the side length CT. We'll give that a unit of 12. We'll give CA a unit of 15. And we'll call this one also 12. DG is going to be 10. 10 for OG. And DO is going to be 12.5. So to confirm that everything is in proportion, we're going to set up some actual proportions. So I'm going to take the side length over here, 12, and set up a ratio to see here with 10, because these two side lengths, CT and DG, are corresponding. They're in the same positions. We want to see if that's the same ratio as side length CA. 15 is to 12.5. I'm writing crooked, sorry. To check this ratio, we're going to cross multiply. Let me get a different color here quickly. We're going to cross multiply 12 times 12.5 is 150. And obviously 10 times 15, whoa, is 150. So since the ratios equal out when we multiply them, then we can confirm that these two triangles have side lengths that are in equal proportion. So we can say that triangle CAT is similar, there's our similar symbol, to triangle DOG by side, side, side similarity. Let's check the next page. The next rule we'll look at is side angle side similarity. This rule, in order to apply it, requires us to have two sides in proportion and one angle congruent. This is two sides in proportion from one triangle to the next, and one angle in one triangle congruent to one angle in another triangle. This equal sign with the squiggle on top, that means congruent. So if we give some labels on these triangles over here, we'll give this one 5 units here, 5 units here, 15 units here, 15 units here. easy to see that these two side lengths are in proportion to these two side lengths because we're multiplying by 3 for each one. And we're going to say that this angle S is congruent to this angle F. So since we have a side and an angle and a side in proportion or congruent to a side and an angle and a side, then we can say that triangle SAT is similar by triangle FOG by side angle side similarity. As a point of note here, the angle that has to be congruent must be in between what we call included between the two sides that are in proportions. Notice when we say side, the angle is sandwiched between the two sides. It literally must be in between the two sides. When we have angle-angle similarity, then all we need are two angles congruent. Remember, that's the congruent symbol. It's implied that the third angle is congruent because we've talked about 180 degrees in a triangle. So if, say, this angle is congruent to this angle, and this angle is congruent to this angle, then we know that the last angle must be congruent to the last angle. If that's the case, then we have enough information to say that triangle FUN is similar to triangle BFA by the angle-angle similarity theorem. Remember, same shape, different size. That's what we're looking for similarity. Well, here is a couple examples to try. Let's say we have a building that casts a shadow of 40 feet. Let's see if I can do a little building for you. Nice tall building. Whoops. So this building's going to cast a shadow of 40 feet. So from the corner of the building, we're going to draw a little picture. Here's 40. There's a 6-foot tall man who casts a shadow of 8 feet. And this guy is 6 feet. The question is, how tall is this building? Well, a couple things we want to do. What if there's a sun out over here and it casts, it's the angle of the sun that makes the shadow. So we're looking like this angle here and this angle here are probably congruent based on the angle of the sun. Oops. And the angle here and the angle here are congruent based on the angle of the sun. So first off, it looks like the two triangles are similar by angle-angle similarity. So that means we can set up a proportion. So if we want to know what the height of the building is, x, well, that x is going to match up with the height of the man, 6, and the length of the shadow, 40, is going to match up with the other shadow, 8. Now to solve this proportion, we're going to cross multiply. X times 8 is 8x. 40 times 6, well, 6 times 4 is 24 with a 0 on the end is 240. To solve for x, we're going to divide by 8. So x is equal to 30 feet. So our building height is 30 feet. We used similar triangles, drew some similar triangles, established that they were similar, and figured that out using proportions. Another common similar triangle problem is one dealing with how to find the length across a lake. It's hard to measure across a lake, but we are able to measure not across a lake and from the edge of a lake out to a common point. How do we know that these two triangles are similar so that we can set up a proportion? Well, if we assume that this line is parallel to this line, these two little triangle arrows indicate that the two lines are parallel. And if this line here is a transversal, then we can say that this angle is congruent to this angle because they're corresponding. And we know that if you look at the small triangle and then the big triangle, that this angle over here is part of both triangles. So of course it's equal to itself. So again, by angle-angle similarity, we know that these two triangles are similar and then can set up a ratio to find the missing side length. So the ratio we want to set up, we want to go the length of the short side of the small triangle, 25, over the length of the whole big triangle. Well, that would be 12 plus 25. Well, 12 plus 25, so now we're going to have 25 over 37. And that's going to be equal to the length of the short side of the bottom, 20 over x, what we're trying to find. When we cross multiply, 25 times x is 25x. 37 times 20 is 740. And when you divide by 25, well, I'm losing it, sorry. Divide by 25, there we go. Then x is equal to 29.6. So we can bring that back over here. So the length of the lake is 29.6 meters. I hope this has been informative. Please let me know if you have any questions.